move on to discuss about breaker point ignition systems. It was used on engines until 1981, which consisted of armature, points, and condenser. Breaker point ignition systems. When points are closed, magnetic field builds up in primary winding. When points open, magnetic field in primary winding collapses through secondary winding. This creates enough voltage to fire the spark plug. Electronic ignition system. The basic difference between the contact point and the electronic ignition system is in the primary circuit. The primary circuit in a contact point ignition system is open and closed by contact points. In the electronic system, the primary circuit is open and closed by the electronic control unit, ECU. The secondary circuits are practically the same for the two systems. The difference is that the distributor, ignition coil, and wiring are altered to handle high voltage produced by the electronic ignition system. One advantage of this higher voltage, up to 60,000 volts, is that spark plugs with wider gaps can be used. This results in a longer spark which can ignite leaner air-fuel mixtures. As a result, engines can run on leaner mixtures for better fuel economy and lower emissions. The components of an electronic ignition system, regardless of the manufacturer, all perform the same functions. Each manufacturer has its own preferred terminology and location of the components. The basic components of an electronic ignition system are as follows. Trigger wheel. The trigger wheel, also known as a reluctor, pole piece, or armature, is connected to the upper end of the distributor shaft. The trigger wheel replaces the distributor cam. Like the distributor cam lobes, the teeth on the trigger wheel equal the number of engine cylinders. Pickup coil. The pickup coil, also known as a sensor assembly, sensor coil, or magnetic pickup assembly, produces tiny voltage surges for the ignition system's electronic control unit. The pickup coil is a small set of windings forming a coil. Electronic control unit amplifier. The ignition system, electronic control unit amplifier, or control module, is an electronic switch that turns the ignition coil primary current on and off. The ECU performs the same function as the contact points. The ignition ECU is a network of transistors, capacitors, resistors, and other electronic components sealed in a metal or plastic housing. The ECU can be located in the engine compartment, on the side of the distributor, inside the distributor, or under the vehicle dash. ECU dwell time, number of degrees the circuit conducts current to the ignition coil, is designed into the electronic circuit of the ECU and is not adjustable. We shall now discuss about electronic ignition system operation. With the engine running, the trigger wheel rotates inside the distributor. As a tooth of the trigger wheel passes the pickup coil, the magnetic field strengthens around the pickup coil. This action changes the output voltage or current flow through the coil. As a result, an electrical surge is sent to the electronic control unit as the trigger wheel teeth pass the pickup coil. The electronic control unit increases the electrical surges into on or off cycles for the ignition coil. When the ECU is on, the current passes through the primary windings of the ignition coil, thereby developing a magnetic field. Then, when the trigger wheel and pickup coil turn off the ECU, the magnetic field inside the ignition coil collapses and fires a spark plug. Advantages of electronic ignition system. Following are the advantages of electronic ignition system. Moving parts are absent, so no maintenance. Contact breaker points are absent, so no arcing. Spark plug life increases by 50%, and they can be used for about 60,000 kilometers without any problem. Better combustion in combustion chamber. About 90 to 95% of air-fuel mixture is burnt compared with 70 to 75% with conventional ignition system. More power output, more fuel efficiency.